Now that we understand the idea of probability, let's investigate what's more likely to happen, less likely to happen, and when things have an equal chance of happening. Something is more likely to happen if there's more chance of picking that outcome. So for example, look at these fish here. I can see that there's way more orange fish than black fish, so it is more likely that if I'm fishing, I will get an orange fish than a black fish. Similarly, since there's less black fish, I could say it is less likely that I would get a black fish than an orange fish. If I wanted to know mathematically how likely I am to get an orange fish, I could show it in a couple of ways. I could show it as a fraction. There are 8 orange fish and a total of 10 fish altogether. So I have a probability of 8/10 getting an orange fish. If I wanted to turn that into a percentage, I would divide 8 divided by 10, and I would get 0.8, which is the same thing as 80%. So I have an 80% chance of getting an orange fish when fishing in this pool of fish. Looking at this spinner down here, I am more likely to get red than any other color because there's 2 sections of red. If I want to know how likely I am to get red, I could see that there are 2 out of a total of 4 sections, so 2 out of 4 would be my probability. If I want that as a percentage, I would take 2 divided by 4, and I would get 0.5, which is 50%. On this spinner, I am also more likely to get red because I can see that red has the biggest amount of the spinner colored in. If I were to take it and divide it into equal sections that are the same as the red, I could see that there's 3 sections that size. 1 out of those 3 sections would be red, so I have a 1/3 chance of getting red. If I divide 1 over 3, it would be 0.33333, which is about 30%. On this spinner, I am least likely to get yellow, least likely to get green, or least likely to get orange, since those are the smallest sections. Again, to find their probability, I could turn them into a fraction, which would be 1/8 for each of those, and then divide 1 over 8 in order to find that percentage. So more likely means there's more of them that I have a chance of getting. Less likely means there's fewer of them, or they take up less space. Now sometimes things are equally likely. There are 2 equally likely outcomes when flipping a coin. It can either be heads or it can be tails. There's no bias where I'm more likely to get heads than tails. It should be the same for each. I want you to go ahead and try flipping a coin 40 times. Keep track in your math notebook how many times it lands on heads and how many times it lands on tails. You're going to need to draw a chart that looks like this so that you can keep tallies of how many heads you get and how many tails you get. Go ahead and pause the movie now so that you can do your experiment. Now that you've done your experiment, you should be able to compare the two and that you should see approximately having the same amount. This is because you have a 50-50 chance. It should be pretty equal for how many heads and how many tails you get. You should end up with about the same number of heads and tails. This means that they are equally likely, or that there's a 50-50 probability. Half of the time it's heads and half of the time it's tails. Now you're going to try the same thing but with the dice. Dice are considered fair because there is an equal chance of getting any number on that die. However, it's not considered 50-50 because there are more than 2 options. I want you to roll the die 60 times and record how many times you get each number. You're going to need to make a chart that looks like this so you can keep a tally of how many times you get a 1 or a 3 or a 6. Go ahead and pause the movie now so you can roll that die 60 times. Now that you've rolled the dice 60 times, you should be able to compare and see that you have approximately the same number for each one of the sides of the dice. There should be about 10 ones, about 10 twos, about 10 threes, about 10 fours, about 10 fives, and about 10 sixes. Once you have this chart, you could further analyze the probability of different events. For example, I could find the probability of getting an even number versus an odd number. For my even numbers, I should have 10, 20, 30, and that would be 30 out of 60, or about half of the time I should get an even number. I could find the probability of getting a 1 or a 2. Probability of a 1 or a 2 would be 10 plus 10, so 20 out of 60, which is about a third of the time, or 30%. So you could use this chart and combine the numbers in different ways and find the probability of getting a whole series of different numbers or different rolls. Now you may be looking at your chart and thinking, I think I'm doing this wrong. In life, there are many reasons why you may not get a perfect prediction for your occurrences. You may get 48 heads and 52 tails. You may have had 8 ones and then 12 twos. We would still consider that fair because there's lots of different reasons why we can have imperfection in our experiments. The first and most common reason would be if we did too few tests. For example, if I took a penny and only flipped it once and got heads, that doesn't mean I'm always going to get heads when I flip that penny. It just means I didn't flip it enough times. Even if I were to flip it 5 times and get 3 heads and 2 tails, or heaven forbid, 4 heads and 1 tail, that doesn't necessarily mean that I'm more likely to get heads than tails. It just means that I have too few tests to actually figure out if I have an accurate result. Another reason why your answer may not be exactly perfect would be human error. We each have imperfections, and we may have a tendency to flip a coin a certain way, or spin a spinner a certain way, which may bias it to make it have a few more heads, or a few more blues, or whatever it is that we're getting. Most likely, if you're not getting exactly like you predicted, it has to do with too few tests or human error. A final reason for our imperfection might be a slight flaw in your situation. So maybe your penny is a little extra dirty on the head side, and that's making it land that way a certain way. Or maybe when someone drew the spinner, they accidentally made one section just a hair too big or a hair too small. More likely than not, though, the reason that you're getting something different than what you would predict in a perfect probability situation is because we're not spinning it often enough. We have too few tests, or human error, we're always kind of biasing it in one way based on our actions.